So similarly, we can find the inverse of the graph of a function by switching the inputs and the outputs. In graph form, this looks like a reflection over the line y equals x. And if you remember from geometry, when we reflect over the line y equals x, xy becomes yx. X and y switch. Right? So when you were graphing reflections over the line y equals x, you didn't even know it, but you were actually graphing inverses. All right, so we want to sketch the inverse of the graph shown below. And I have to say, linear functions are the easiest. Right, so I believe I have this in your notes already. The line y equals x, that's what we're reflecting over. Anytime you want to graph the inverse, the first thing you want to do is graph the line y equals x. Right? So I'm going to just put graph y equals x first, because that will help you. All right, so now all we have to do is switch our x's and our y's, our domain and our range. Right? And so it's easy we don't even need too many points on a linear function. If we've got 2, we're good. It's good enough. All right, so let's see what I see this point here, 2, 0. Oh, excuse me, 0, 2. And this point here. All the rest of them I'd have to estimate. And that's, I have to say, it's hard to notice the x and y axes. I'm really relying on that red dot there. 1, negative 3. I think that's it. Everything else is an estimated point. But fortunately, we only need 2 points for a line anyhow. All right, so we have the points 0, 2, and 1, negative 3. And that's our function. We'll just call it f of x. For the inverse, we just switch them. So f inverse function, we're just going to switch. So instead of 0, 2, we have 2, 0. Instead of 1, negative 3, we have negative 3, 1. Right? And so let's graph that. Right, so we've got 2 zeros, going to be right there. So notice our y-intercept became our x-intercept. And negative 3, 1 is going to be right here. All right, let's graph that. And then I'm going to fix it because my line came nowhere near where it was supposed to have gone, but that's okay, it never does. I always have to do this part. Okay, and it's a line, so it is going to keep going. Let's take a look at, and so now if you kind of hold your head sideways, right, so you're looking up y equals x, right, notice that what you see on the, I don't know if you call it right or left, but on one side of the line y equals x, so what you see over here, right, should look like the mirror image of what you see over there. Right? And it is. Let's look at the slopes on these two lines. All right, so slope of the original function, f of x. All right, so between 0, 2 and 1, negative 3, it's got a vertical change of negative 5, right? It's going down 5. Horizontal change of just 1. Right, so that's going to be a slope of negative 5. How about our inverse? Let's look at its slope. All right, so of course the 2 points I'm going to use are the ones that we have graphed there. I'll label those. So negative 3, 1, and 2, 0. All right, so vertical change. Right, still also negative. So vertical change is negative 1. We're going down 1 and to the right 5. So those lines are not perpendicular of one another. Right? Switching x and y is not going to give you a line that's perpendicular. But notice that the slopes are reciprocals of one another. So if it's linear, a linear function and its inverse have slopes that are reciprocals. Reciprocals. Right, so one last thing before we do one more problem. I'll do another problem. Is this a function? Is the inverse a function? Right, well, first of all, does our, and I'll take a purple line here. All right, does our original function, the purple line, pass the pass the horizontal line test? Right? Do I go through more than one point? Oh, excuse me. Oh, that would really help if it was a horizontal line. Let's try that again. That's the next part of my. Does the red function, the original function, does it pass the horizontal line test? Right? If I have a horizontal line, does it go through it more than one place? Well, of course not. Right? It's not turning around, it's a straight line. Right? So the linear function passes the horizontal line test, and which means our, whoops, I wanted that to change to a vertical line, which means our inverse will be a function, and we can see that from the vertical line test. Thank you, line. All right, so we're going to write one more thing. All right, so the inverse of a linear function is a function. And that's true all the time. Oops, let me fix that. And so our original graph there, f of x, passes the horizontal line test. And we know, and that's because it's a one-to-one function. Every x is matched with one y, and likewise every y is matched with one x. Right? Otherwise it wouldn't be a line, right? It would be turning around if the same y could be matched with more than one x. So inverse of a linear function is a function. F of x passes the horizontal line test because it's a one-to-one function, and therefore, this is a symbol for therefore, f inverse is a function too. All right? So we're going to try to always talk about our whether or not our inverses are functions or not. All right, let's do one more in this podcast, and then I have more in another podcast that follows this. All right, so let's try this one. A little trickier, it's not a line. All right, so, and I did not, and this one's not in your notes. Let's see if I can copy this. I can. Usually I can't. You know, just go to whatever box it feels like. Paste. There we go. So here's our handy dandy. And the nice thing about this particular graph is the coordinate plane is actually square. The last one it wasn't square, and so I had to adjust my line so that it actually was y equals x. All right, so this is the graph of y equals x. The red graph, red again, is our function f of x. We want a graph. We don't even have directions on this one. This was a brand new one. We want a graph, or we want to find F inverse. And we're going to do that by graphing. Makes it a little glitch there. My H keeps jumping up, but I think that's good enough. All right, so a little review of the steps to do that. Step number 1, you need to graph f of x, the original function, if needed. Here it's already graphed for us, so we are skipping that. By the way, this I didn't actually write the steps in your notes, I don't believe, so I would suggest I went through them, but I didn't necessarily write them as steps. Maybe you should write those down. That would be a really, really good idea. All right, so let's put little notes here. And what these are the notes for. It's the steps to graph our inverse, f inverse. All right, so first step is graph f of x if needed. So if you already got the graph, if you already got that f of x graphed, that step is done. All right, second step is to graph y equals x. That's what you're reflecting over. Right, so that's your line of reflection. Third step, identify points on f of x. Right? On your original function, you want to identify some points. Let's do that right now. All right, so we have the two with the big red dots on them, but we have some other ones too. Try all possible not to estimate the points unless you need to. Sometimes you will need to get more points. Let's use the ones that we know, and then if we need to, we'll estimate some points if we have any trouble. So this is the point -1, 1. Let me write that a little nicer. Then we have the point 3, 3. Do we have any others? Oh, yeah, we have one right here. Looking for good points that are a little easy to identify. That one is 0, 2. That looks like 0, 1, 2. My parentheses came up too big. There we go, 0, 2. And right here, that would be 8, 4. Those are the only ones I'm sure of. Everything else I'm going to have to estimate, and let's try to work with those. All right? So then you're going to switch x and y on these points and graph. Because those switched x and y are points on f inverse. All right, so I'm going to write them over here. So we've got our points for f of x. We've got -1, 1. And you know, as I'm doing this, I'm thinking I should really give you this particular graph. So I'm going to make sure before you watch this podcast that you get this graph so that you can do this one with me. All right. And as I'm saying, write these things down. Since I'm going to give you the graph, not going to give it to you all filled out, but I'm going to give you those steps. That's how nice I am. All right, so f of x. So now that I say write them down, you'll be looking at me like, hey, they're already here. And now you'll know why, because I decided to give them to you. F of x equals -1, 1, 0, 2, 3, 3, and 8, 4. And that looks like an 11, so let's write that nicer. All right, so you write that part down. All right, so now we want the points. I'm going to use blue, so it's a different color, for f inverse. All right, and so we just switch the x and y. So this is going to be 1, -1, and 2, 0, and that one's not going to change at all. 3, 3, and 4, 8. All right, let's graph those. Okay. So we've got 1, -1, and 2, 0, and 3, 3. That's nice. And you know how we would know that we have to, so notice that 3, 3 is on the line of reflection, right? So that means if a point's on the line of reflection and we're reflecting over it, it's got to still be on the line of reflection. So there we have that point there. And then we have 4, 8. And that's right here. And I think those are enough points for you to figure out how to graph this. And there we go. That wasn't too bad. That's all we needed. Right? Now take a look at, do we have mirror images on either side of those lines? Well, we do. But here's how another way we can tell. I'm going to get a handy dandy purple line. All right, so let's take a look here. So whenever you have a reflection over any line, not just y = x, any line at all, right, and you connect corresponding points, so these are the corresponding points, right, and my line is still not straight. There we go. Now I'm connecting them. Right, when you connect corresponding points, the segment that connects those corresponding points is going to be perpendicular to your line of reflection. Let's write that down. Right? So a segment connecting corresponding points. And then when we're doing, this was geometry, we had a pre-image and an image. This time our pre-image is f of x, and our image is f inverse. Right, so segment connecting corresponding points is perpendicular to the line of reflection. Oops, I'm going to have to move down a bit. Let's see if that's so. All right, so we know that y = x, slope is 1. Right? How about our purple line here? Well, notice we're going down 1 to the right 1, down 1 to the right 1. This has a slope of -1. Let's see if it connects all our corresponding points. And I'm going to try to make sure I go in a straight line and not mess up my line. That one looks pretty good. Well, since it's on a line of reflection, right, those two, anything connects them because they're the same point. So let's go into the next point, pair of points. Does our perpendicular bisector there, is it connecting our points? Yes, it is. All right, so we can use the fact that a segment connecting corresponding points has to be perpendicular to the line of reflection to check. All right, so this is a great way to check, and sometimes it can help you get more points if you're stuck. All right, so you can use this fact to check your graph of f inverse. That little fact all on its own won't necessarily be enough, but combined with your steps, which I didn't finish writing down. So switch x and y on the points and graph, which we did, and then connect the points to graph F inverse. And just a little hint, make sure it is a mirror image Ugh. You're not going to be able to read that. Make sure it is a mirror image. Just put this in, f of x. So as you can figure out, you don't need to worry about writing that because I already gave the green parts in your notes. The only thing I didn't give you is I didn't give you anything else. Original graph, and I'll give you the green parts. All right, so here's how we graph our inverse, how we find our inverse by graphing, and we graph by reflecting our f of x over the line y equals x. Right? So all we have to do is use the same rules from geometry to do a reflection over the line y equals x, and that simply is you just switch x and y, right? And then you make sure you're actually a reflection, because notice we don't have all the points here, right? So whatever our function does, our inverse has to be a mirror image of that. By the way, did you recognize what the equation of our original function is? Okay. We'll talk about the inverse later, but how about the original function? Does it look familiar, like a graph you've seen before? Hopefully you recognized that f of x was actually a square root, a graph of a square root. And in this case, there's no dilation or reflection to it. It's just translated, and it's translated one to the left and one up. So this was f of x equals the square root of x plus 1. Oh. Now move it over here because I can't fit the last little piece in. F of x equals the square root of x plus 1 plus 1. One to the left and one up. And there we go. All right, so in the next podcast, you'll see me reflect some more graphs. I'll give you more information. Before we leave this graph, let's talk about, real quickly, is this a function? Right? Does our graph, does the original pass the horizontal line test? Is this a one-to-one function? Is every x matched with one y? Well, this is a square. Our original function is a square root function, right? So when you take a square root, you don't get two answers, right? You get one answer. So this is square root. And this is a one-to-one function. So when we're graphing, don't confuse, taking a square root of both sides and plus or minus. That's different. That's solving. But when we're graphing a square root, it's a one-to-one function, right? 1y for every x. So our inverse therefore, the inverse graph is a function. So you can add that too. I'm going to move our little slope over here. I'm going to leave that line there just so you can remember that. And I'm just going to label this as f prime of x, and we're not going to talk about what the equation for that graph is until a later lesson. Thanks for watching this podcast, and then make sure you watch the next two podcasts. The last one is a little bit on the shorter side. Actually, both of these are a little on the shorter side than this one was, now that you got the hang of it. All right, so bye for now, and thanks for watching.